Okay, today we're going to be working at trying to find the area of complex shapes. I've often heard complex shapes also referred to as composite figures because it's made up of or composed of regular or not regular, because sometimes they're not regular polygons, but sometimes they're just ordinary polygons. Anyhow, we have a shape here, and it is a complex shape or a composite figure, if you will, and we're going to try to figure out the area of the total shape. Now, I have worked on this one in the past, and there's at least 4 ways I could break it down. I could figure that out by breaking it down into 2 trapezoids. One trapezoid would actually wind up being an isosceles trapezoid if I put my line here, and then the other one would be like a right trapezoid. I could also break it up like a square and a right trapezoid. I could also make it a rectangle and a right trapezoid, and I could also make it a rectangle and then a rectangle and a triangle. I've got students in the room, so I'm going to let them help me figure out how to break this one down. What are some shapes that they think would be good ones to isolate here? All right, students, let me know. Let me hear it. Let me hear it. What should I make that complex shape or that composite figure? What should I break it down into? All right, Sierra.
A square.
So you think I should make it like a square and a right trapezoid like this?
Yeah.
That's what I'll do then. So what I'm going to do is I'm going to find the area of this square and then the area of this trapezoid. And then what I will do is I'll add those areas together to get the total area for the shape. My formula for finding the area of a square is area equals side squared. And since one side is 4 centimeters, the other side is 4 centimeters, I can say 4 squared, and area would equal 4 squared equals 16. My unit measure is centimeters squared. Now, one of the things I want to point out to my students is always put your unit of measure with your answer. You have to put your unit measure. If we didn't put our unit measure here, we might think perhaps we're talking about feet square or inches square or yards square. We don't know. So always put your unit of measure. Now, let's figure out the area of the right trapezoid. Okay, the formula for a trapezoid is this. Area equals 1/2 the height times base 1 plus base 2. Area equals 1/2, and the height here, this height is going to go from like here to here. Any point along here you could say would be the height. Now I know that from here to here is 7 centimeters because, it told us that here. From here to here is 4. So boys and girls, what we need to do is we have 7 for the total height, and we know from here to here is 4. So what's the height of our trapezoid? Okay, Morgan.
3 centimeters.
3 centimeters. So I know my height is 3 centimeters. So I'm going to go ahead and I'll just label that here. And I should have made that more of a broken line because I just want to indicate it's a height and not a line. And what about our base of this, our base 1 of this trapezoid? What can we say is the base 1 of our trapezoid? Like if I were to say from here to here is base 1, what is the length here? What is it?
13.
All right, 13 centimeters. So I can say 13 centimeters here plus, okay, what is this base from here to here? Now, we know from here to here is 4 centimeters because this side is 4 centimeters and this side here is congruent to it, so this is 4 centimeters. And from here to here is 5 centimeters. So what can we say is the base 2? All right, what do you think, Carissa?
9 centimeters.
Yeah, 9 centimeters because 4 plus 5 is 9, and it's centimeters. So I'll say base 2 is 9 centimeters. Okay, so half of 3 is 1.5, and I can say 13 plus 9 is 22. Y'all agree with me?
Yeah.
Alright, so I'm going to do a little bit of mental math here. I'm going to break this number down. So I can say 1 times 22 is 22. Half times 22 is 11. 11 plus 22 is 33. And my unit of measure is centimeters squared. Am I finished, boys and girls?
No.
No. My next and final step will be to add the area of our square, which we said was 16 centimeters square, with the area of this trapezoid, which we found to be 33 centimeters square. So I know that 3 and 6 are 9. And I can say 1 and 3 is 4. So the total area of the figure is 49 centimeters squared. Now, like I said, I could have broken that down in several other ways. There's at least 3 other ways I could have broke this down and solved it. But that's what you suggested, Sierra, so that's how we did it. Does anybody have any questions about what I have shown you thus far? Okay. Now, if I were to connect the math practice to this, I use what I know about how to find the area of polygons in order to break or decompose this complex figure down to get the total area. And nobody has any questions on this? How many of you feel confident that if you had a similar shape, you could figure it out too? Okay, I see a lot of hands up, which is pretty good. Now, we'll point something out to you. Sometimes you're going to have to come up with ways to figure out values. It did not tell me what this base 2 was. It had nothing in it telling me what this value here was. I had to know that if this side is 4 centimeters, then this will be 4 centimeters. And if I combine that 4 centimeters with 5 centimeters, I can figure out how long this base 2 is. So you're going to have to do some things like that. You're going to have to kind of do a little bit of computation to figure out some of those values that you're going to need to solve for these areas.